everybody. Happy Monday. Hope you guys are getting ready for your iReady testing later this week, but you're still coming to your morning meetings every day because we do love to see you guys at that time. Last week for science, we learned all about solids, liquids, and gases. We know that there's plasma too, but we're focusing on those three. And we learned that once those are here, once you have matter here on Earth, it cannot leave. It can change though, physical or chemical changes. And that's what we talked about last week. And we briefly discussed the law of conservation of matter. And you guys should all have this PowerPoint, so if it's a little blurry for you to see, you can go back and look at it on your Google Classroom under your science, and you'll be able to see it. Hopefully soon I'll get that document camera and be able to share my screen and show you that way so that we don't see that blur. The law of conservation of matter tells us that the amount of matter in something stays the same even after it's changed. So if I were to just go crazy and just rip up this paper in a bunch of pieces, once I collected all those pieces, it would have the same amount of matter as it did before I ripped it apart. Even if I burnt this paper, okay, so if I lit it on fire and it turned into ash and some gases, if I were able to collect those gases in that ash, it would have the same amount of molecules, the same matter amount as it did before it was burnt. So once again, even though it can be changed, it cannot be completely destroyed. It cannot leave this earth. So just one of the examples I have is, think about a big computer and all the parts of a computer and all the parts inside a computer. Let's say you weighed it and you got your total weight. And then you went bang, crash, smash. You got so mad at that computer it ended up in a million pieces. As long as you collect all those pieces and weigh them, it's going to weigh exactly what it weighed before you banged it all up. Here's a couple of questions that help us practice this law, the law of conservation of matter. This says the mass of a piece of construction paper is 8 grams. The piece of construction paper is torn into 4 equal sections. When weighing the 4 equal sections together, what is the mass? Well, you're weighing them together, so it's going to be 8 grams. This one says Ashley creates a clay bowl that weighs 1 pound. What is the weight of the clay used to create the bowl? Well, it would also be 1 pound. Even though you took that slab of clay and molded it into a bowl, it still has the same amount of molecules, the same matter. Bob puts 200 grams of ice into a pitcher with 900 grams of water. He gets distracted and comes back later and finds that the ice has melted in the water, which would be what kind of change? Yep, that would be a physical change. How many grams of water does Bob have in the pitcher? So, 200 grams of ice, it melted. Now it's going to keep the same amount of matter, and it's going to be 200 grams of water. So it's going to be 200 grams of the ice that melted plus the 900 grams of water already there for a total of 1,100 grams. Pretty simple, huh? All right, we're going to skip on through. There's a lot of these practice questions if you guys want to practice through and find your answers. Well, there sure is a lot. And we're going to keep on to our next part of our unit, which is energy, conservation, and transfer. Now, something that is important is this word energy. I told you already, it's going to be in every single science unit that we have this year. And in this unit, it refers to heat. Did you guys know that heat is energy? Heat has energy? That's what we're going to be talking about the next couple of days. When you add heat to something, you're adding energy to it. So I gave you the example the other day of my wet hair. Well, if I add the hair dryer, which is heat, to it, my hair starts to get dry. Did that water from my hair disappear off the face of this earth? No, it turned to water vapor. We heated up that water in my hair, and those molecules got energy and started moving around and got further away from each other and became a gas. So remember that energy is heat. heat is energy. And the more heat something has, the faster those molecules are going to be moving around. So let's take a break right here because tomorrow we're going to learn about heat transfer. But first, let's make sure we understand the law of conservation of matter and that we understand that heat is energy. So we're going to take some notes real quick if you want to get out your notes. I'm going to just switch my screen real quick to the smartboard. And go ahead and write the law of conservation of matter. Okay, can you see that? And we can say that this law states that the amount of matter in anything, in something, stays the same after it is changed. All right, so there we can see the screen a little bit better. And to have a little visual of this, we can take our piece of paper. We'll say it weighs 4 grams. And if we take the same piece of paper and tear it into all these little pieces, it's still going to weigh 4 grams. All right, and you guys can go ahead and pause this because I'm going to keep on going. We also want to remember this big word we're going to see all the time in all of our units, energy. And in this unit, we want to remember that energy is heat. The more heat there is, the more energy there is. And when we give that matter more heat, it can change. You guys have probably seen that all the time with water boiling or with fire or with touching something and it's hot. You've seen that happen. So when you add heat, you're adding energy and there's going to be a change and those molecules are going to start moving more. And we're going to keep on talking about that this week. So you guys keep your notes going. I hope that you have your notes from last week as well and just add them to this because it's the same unit. Add these notes to your old notes. And we'll see you later. Bye guys.